this is Matz, the creator of the Ruby language. And today I'm going to talk about MJIT, but first of all, I'm awfully sorry not to be here, RubyConf Indonesia, just because I was so busy, so my schedule did not allow me to be here. To visit Indonesia, but I'm very glad to have those conferences especially in Asia, because I was born and raised in Japan, and as a part of Asia, so as a person who raised up in Japan, so that I'm very glad to be technology will nourish in Asia. So that if you have any questions and issues, so that I'm sure that my coworker, the Koichi, should be here, so that ask him any question, or ask him to delegate any questions to me. So let's start about it. My name is Matsumoto Yukihiro. Or Yukihiro Matsumoto in English way, but my name is a little bit difficult to pronounce and a little bit difficult to remember, so that everyone outside of Japan call me Matz, which is kind of the nickname of myself. Then, so I'm pretty famous, a famous programmer, but I don't think I'm a genius programmer. So I rather consider myself as a mere programmer. So as a programmer, my skill is relatively okay, but I'm definitely not a genius. I consider myself as a language designer, so that I know about the language in general. So I consider myself as the big fan of programming language in general. I started my programming career in BASIC, which is very primitive programming language, and then I started to learn about Pascal, C, and Smalltalk and Lisp. And those languages are pretty exciting for me, so that I consider about creating my own programming language. So it was my high school dream. So, but in those days, it was early 80s, so that long time ago. We didn't have internet then, so it was kind of like a Stone Age. So that I didn't have any knowledge, and I didn't have any, skills and about the creating programming languages. So that I couldn't make it by myself in my high school age. I entered the university, majored in computer science. Then I studied a lot about the computer science in general and the programming language and the compiler theory. Then after I graduated the school, so I started programming Ruby in 1993. So it was almost 10 years later when I first dreamed about creating programming language. So since then, almost 24 years, that 24 years I have been a designer of programming language. Of course, I worked as a programmer to create my own programming language, but my focus and emphasis is on the designing programming language. So in the design of programming language, we see a lot of contradiction or trade-offs in design, because it is quite difficult to imagine the usage of programming language beforehand, just because you can do anything, right? You can write web application in Ruby, you may write a game in Ruby's, or you may write some kind of admin tools in Ruby. So it is so the background or the situation of usage is different from user to user, so that there might be some trade-offs in design. So that because of those trade-offs or contradictions, designing language is so hard. So the one reason is Ruby is so popular. So Ruby is popular. That everyone, so many programmers in the world use Ruby, mainly to create web application, but for creating games or maybe creating embedded systems, or maybe in, say, whatever reason. So in the history of Ruby programming language, it has helped many programmers or developers. And then it has served almost 25 years. So the next year, the year 2018, so we are going to have the 25th anniversary of Ruby, 25th birthday of Ruby in February 24th. So back to the issue. So many software written in Ruby, and then Ruby is matured. So and then Ruby is stable, and Ruby should be stable. Just because if we make some kind of that incompatible change, so that would break so many software. So the Ruby expected to be stable. So the compatibility very matters, and we need to keep compatibility in design of Ruby, just because we don't want to break any existing software written in Ruby. Otherwise, so many users scream, so because their software would not execute correctly with new version of Ruby. So they need to migrate, paying some effort to change their software. So of course, people don't want to change their software due to the version of the language. So users would be sick of compatibility hell. So then eventually users will leave. So the Ruby community in general will decline. At the same time, Ruby has a lot of technical debt in the past. Unfortunately, we are not perfect in design of Ruby, so that we made a lot of mistakes in design. For example, in very early stage of Ruby development, I borrowed many ideas from our predecessor, Perl programming language, and then we borrowed many ideas from the language, Perl language, but I think I brought those languages too many. So for example, we have so many of dollar something weird variables that is very cryptic and hard to understand. So I actually regret them. There are some theory named the broken window theory. So, which is if we keep drawbacks like we broken windows in town, so the entire block will be unsafe, insecure. So the entire quality will decrease. That is broken window theory. So if we stop progressing, developers will leave because Ruby is no longer a good language, or so the attractive language. So there's a contradiction. So we want to keep compatibility, but at the same time we want to make progress. Otherwise, people will leave. The developers will leave. But if we change the language a lot, the users will leave. So what? If we, no matter we make changes or not make change, so we are going to lose users or developers. That's pity. So for example, some kind of tragedy had in the past. For example, between the Ruby version 1.8 and 1.9, we made some kind of a huge changes that is incompatible. So many programs run on Ruby 1.8 did not run on 1.9 because we replaced the virtual machine. So we introduced many encoding stuff to support Unicode and other encodings better. So in that sense, we lose some kind of the compatibility. And then that makes the part of Ruby community keep using old version 1.8 for a long time. So it did take us to migrate from 1.8 to 1.9 for 5 years. So 5 years. So in 5 years, we suffer some kind of the community division. Part of us using 1.8 forever, then part of us migrated to 1.9. So we core developers mainly work on 1.9, so newer version. So the people using 1.8 is left behind. So that kind of a very tragic situation for the Ruby community. The other languages, for example, Python has similar situation. Python 2 and Python 3 are different. So had some kind of compatibility issue. So the Python community, it took Python community to more than 10 years to migrate to 1.3, and it is under the process of migration still. So it took Python community to migrate for more than 10 years. Actually, the end of life of Python 2 is declared to be year 2020. So they have 3 more years to finalize the life of Python 2. Well, so that kind of community division is kind of tragic. But we have even worse tragic in other programming languages. For example, in PHP community, the people create the better, the core team, they created the better programming language named Perl 6, which has the better Unicode support and the tons of good features. But at the same time, the change was so drastic, and then very few people in the community use the newer version. So the project PHP 6, version 6, was cancelled. So that they start again from PHP 5 to create a newer version, PHP 7. Similar thing happened in the ECMAScript. The ECMAScript version 4 was very enthusiastic. So the adventurous newer version. It has tons of new features. But those new features are incompatible to older version, and at the same and besides that, they are very complex. So the community didn't choose to use ECMAScript 4, so that particular version, ECMAScript 4, was cancelled. So now we have the ECMAScript 5 newer version and the ECMAScript version 6, and continues. So if we make some kind if we take some kind of incompatible change, the project may cancel. That is so tragic. So for us programmers, it is tempting to throw everything away because we have the technical debts and we have a lot of design mistakes and drawbacks. But then start from scratch. But it's not a good idea. And it's not only for software, so for politics as well. So for example, in Japan, so we have the new political party that claims the resetting the politics. But it is typical syndrome we suffer to throw everything away. That that does not guarantee success, or probably the maybe 1 to 9, a probability of 1 to 9, we will fail by resetting, throwing them away. And that kind of syndrome is derived from our mindset. So that kind of things can be applied not only for programming, not only for politics, but everything. So it really works well. That kind of symptom is called second system syndrome. So we have to move on step by step. So not throwing away everything, but we have to make our progress step by step, very carefully. But there's a hope. So we have some kind of the community division in Ruby 1.9 and 1.8, and then Python 2 and Python 3. The Ruby 1.9 takes 5 years to migrate to be, and then Python 2 took more than 10 years. So the one reason is Red Hat Enterprise that uses Python 2 as a default, but the other reason is motivation. So the Ruby 1.9, unlike Python 2 and Python 3, the performance is about the same at the beginning, at least. But 1.9 introduced a new virtual machine, which is called YARV, and it was far faster than 1.8. So the performance is the key. Ruby is not designed as a fast language, but then that means the performance is not a primary goal. But no one complains faster Ruby, so performance is important. In fact, we have made Ruby faster. New Ruby comes every 12 months, so every Christmas Day we will release the new version of Ruby since Ruby 2.0, since Ruby 2.1 I mean. Then each new release runs 5 to 10% faster. We improved the garbage collectors, we improved the virtual machine, we have improved and applied many optimization to the libraries and the interpreter. But I don't think it's enough, because everyone thinks Ruby is slow. Mostly because it's the image of the past. So yeah, I admit Ruby 1.8 is pretty slow. It was pretty naive implementation of the interpreter, just because I made that. So my primary focus is not the performance, but the design. So that I create the Ruby interpreter to work correctly and with the right language, but the performance was not my the primary focus. Then we replaced the better version. We replaced my interpreter, slow interpreter, by a faster virtual machine called YARV. So that image, which is Ruby was slow, is diluting people still after, I don't know, after 10 years of history. So we need to make some kind of impact to recreate the image of Ruby performance. So we coined some kind of catchphrase, which is Ruby 3x3. That means that to make Ruby 3, the newer version, 3 times faster. So the goal is pretty straightforward and simple, and performance is justice. So that if we create a faster programming language, the image that community has will be improved. But technically it's pretty difficult, because actually far more difficult than you may think, because in the history we took the low-hanging fruits, so that we have to make some kind of a drastic change to make Ruby dramatically faster. And then, in addition, Ruby should keep being Ruby. So we cannot change Ruby for the sake of performance. So if you do want the faster programming language, so you can go to, say, Java, Go, or whatever. So there are tons of faster programming language designed to be fast. But it's not our goal. Our goal is not make Ruby fast language, but we want to keep Ruby as enjoyable as current Ruby, but still execute fast. So we want to provide the faster virtual machine, faster compiler, without modifying the language for the sake of performance. So that we have some rules and regulations for Ruby 3x3, which is the first one is memory usage. So we have the time and space trade-off. The program's software runs faster than when it consumes more memory. So the JRuby is faster than Ruby in general, but it's due to JVM. So thanks to JVM, but JRuby consumes more memory. In micro benchmarks, it consumes 100 times more memory, and more realistic benchmarks of the carrot, which I explained later, that JRuby consumes 17 times more memory. So Ruby may run on memory-tight environments. So for example, the Heroku smallest dyno only has a 500 meg, which used to be a huge memory space, but in those days that is nothing. So if we consume more memory, the newer version consumes more memory. So those web applications will not run on the smallest dyno. So that's a problem. Well, decent PC only has 2 gigs of memory. Embedded systems has even less. So the rule number 1 of Ruby 3x3 is it should be configurable to use as less memory as Ruby 2.0. So, and the second one is dependency. Ruby is a long-lived project. It's 24-year-old, as I said. It started 1993. So by the way, Ruby will turn 25 on February 24th. So we are planning some virtual event to celebrate. So back to the story. So Ruby is a long-lived project. Depending on outside project, third-party project is kind of dangerous because JIT, just-in-time compiler, is promising technology to improve performance. There are some JIT supporting software. For example, LLVM, LibJIT, GNU Lightning. Those are the JIT supporting software. We don't have control over those software. So unless you are Apple, if you are Apple, you can buy those software. But we are not Apple. So we are mere open source programming language community. So those software may have bugs. They may not put our issues in priority, or maybe the project would be abandoned. So we may need to forget and maintain it, the JIT software. So creating JIT software is not our primary focus. So we focus on languages. So it's not good to add new software to maintain. So sounds silly, but very few projects survive more than 20 years. So the rule number 2, it should not be dependent on third-party software, especially libraries. So the third one is maintainability. The overall maintainability matters. Unmaintainable code stops evolution. So open source software that stops evolution gradually dies. So the rule number 3, it should be as simple as possible for better maintainability. And the fourth one is the baseline is Ruby 2.0, not 2.4. The latest Ruby version is Ruby 2.4, released on the last Christmas, and we are going to release the new Ruby in Ruby 2.4. We have done a lot of improvement, as I told you. We introduced the generational garbage collector, incremental garbage collector, open orders hash table, and a lot of other improvements. So we have the 5 to 10% improvement each year. So Ruby 2.4 is faster than Ruby 2.0. Ruby 2.4 consumes less memory than Ruby 2.0. So we want to include those improvements to measure, to our measurement. So rule number 4, it should be compared to Ruby 2.0 as a baseline. So the last regulation is no micro benchmark. We have some kind of alias shootout games for the micro benchmarks and the unrealistic benchmarks, but they are only games. So they don't reflect real-world behavior of applications, especially web applications. So we have to build some kind of standard benchmarks. Those benchmarks should be artificial for the sake of the reproducibility, but reflects real-world behavior. So we are going to create some kind of web application benchmark suites based on this course. So you can see that those benchmarks from this URL: https github.com noah-gibbs rails ruby bench. So this is one of the candidates of our standard benchmark to compare Ruby 2.0 and Ruby 3.0. So those benchmark suites are created by Noah Gibbs, who is in charge of the Ruby 3x3 full-time, hired by the company named Appfolio. And then we have the other benchmarks, which is AutoCalc benchmark. AutoCalc benchmark is the Nintendo Entertainment System emulator, which should run in 60 frames per second. You can find AutoCalc benchmarks from here: https github.com MAME AutoCalc. Those benchmarks, AutoCalc benchmarks, is created by Yusuke Endo, who is now working on the Ruby, the full-time committer. Works as a full-time committer hired by the company Cookpad. So rule number 5, it should be compared to using standard benchmarks, not micro benchmarks. So the Ruby 3x3 project is very hard. If we classify the hardness in hard, harder, hardest, impossible, hell, it is nearly impossible, even with JIT technology, just-in-time compilation. We have, as I told you before, there are some JIT supporting software, for example, LLVM. So LLVM is used by many programming languages like Rubinius and Crystal and Julia. It is portable and highly optimized, but the JIT API, unlike LLVM itself, the JIT API does not have many users, so those API often changes. And then, as I told you before, depending on LLVM, it introduces us a huge dependency to the big third-party software. So LibJIT and Lightning, both from GNU project, and then those are less widely used, and it comes with the LGPL, lesser GNU general public license, which is somewhat incompatible with our current Ruby license, which is BSD, fundamentally BSD license, 2-class BSD license, and we, along with our own license. So then dependency problem still exists for the LLJIT and Lightning. How about creating our own JIT system? So, but the JIT system is quite difficult to maintain and create and maintain, and we have to keep many CPUs and all operating systems. So So even though we don't have any dependency problem if we create our own JIT software, so that huge drawbacks we cannot ignore. So it is somewhat difficult to create the performant JIT system. So that's kind of the technology difficulty is unacceptable for us. So we don't have good candidate for JIT systems until this year. So we have something very drastic and promising, which is named MJIT. MJIT stands for MRI JIT, Matz Ruby Interpreter JIT, and you can find the source of MJIT from here: github.com, vn Makarov, Ruby tree RTL MJIT branch. It is written in Vladimir and Makarov from Red Hat, who is in charge of who is in charge of the GCC GNU-C compiler for a long time, last 20 years, and he's very smart and pretty expert about compilers. So he's also the author of Open Address Hash Table, which improved the last year's Ruby 2.4 performance. So the point is, MJIT uses RTL and use GCC and clang, and it is method JIT. RTL stands for the Register Transfer Language, and then in virtual machine we have two trends, which one is stack internal representation, the other is register internal representation. The current YARV use the stack-based internal IR. So get local, get two locals, then plus, then set local or something like that. And then the RTL is the register-based IR. So the plus, and it takes two arguments, and then one destination or something like that. The YARV uses stack-based IRD. RTL uses the stack register RTL IR. Stack-based IR is simpler and shorter as a bytecode. But the register-based IR creates less instructions. The register-based IR creates less memory traffic, and the register IR runs faster. That is kind of controversial, though. So then, Vlad replaced the YARV by RTL VM, which does faster to 2.4, and which costs as much memory as 2.4. So it's not improving that much. So the performance and the memory consumption are about the same. So that might unsatisfy you, but then he implemented JIT. So remember rule number 1. So it should be configurable to use as less memory as Ruby 2.0. So if we configure to avoid JIT compiling, so the RTL VM, new VM, runs as fast as current VM and consume as less memory as the current virtual machine. So, but if we configure to consume more memory and use JIT, so it runs faster. RTL VM without JIT runs as fast as Ruby 2.4. The RTL VM consumes as much as memory as Ruby 2.4. It is the best. It's the baseline. The RTL can be JIT compiled into C files, then compiled to machine code, which is contained in the .so file, then use command line gcc clone, then dynamically load it. So the current implementation generates YARV code in memory and executes YARV code in memory. Then the baseline is the generate RTL in memory and then execute the RTL in memory. But MJIT generate RTL, then generate C file from RTL, then compile .c by GCC, then load compiles .so file, then execute. So the figure is kind of like that. MJIT create the C code, then CC compile to .so file, then using dynamic loading to load those compiled files, then execute. So benefit, we don't have no tricky dependency. Of course, we use the GCC and or CLAN, the compiler, as an external software, but the command line interface of compilers is stable for last 30-40 years, so we can rely on that. So, and compilers, C compilers are very much ubiquitous. If you if you want to have the performance boost, you need to install the compiler, of course. But once you have installed the compilers, you will have the huge performance improvement. Compilers are stable and portable and highly optimized. So you may have concern. It is overhead, right? So it has higher compiler cost. So generating C code, executing the compiler, passing C code, code generating from C into files, and dynamic loading SL files, those are overhead. So he had some kind of the countermeasures. So he created the minimized header to reduce the compile time, and then he introduced some kind of worker thread for the parallel compilation. So once program runs, the worker threads are spawned, then those compilers are controlled by those worker threads. So it is in parallel. So that you don't have to worry about the slowdown of compilation. So result, default out is as fast as YARV, default out has less memory as YARV, MJIT runs as far faster than YARV, MJIT consumes more memory than YARV. The future. The MJIT is pretty much early stage. It only started this year, so that we don't have no inlining yet or speculative yet. MJIT can be even faster. So we ran benchmarks. So in summary, MJIT is far from completion. Our benchmarks are incomplete, but still use monk. And then we still use this micro benchmarks. But by that measure, MJIT runs far faster than YARV. MJIT consumes more memory than YARV, and MJIT runs faster than JRuby. And in this benchmarks, I mean, MJIT consumes less memory than JRuby. By using micro benchmarks, MJIT runs 6 times faster than Ruby 2.0, and MJIT consumes 4 times more memory than Ruby 2.0. And for JRuby, 2.5 times faster and 200 times more memory. And off the count benchmarks, MJIT runs 2.8 times faster than Ruby 2.0. So it is kind of close to Ruby 3 by 3. MJIT consumes 1.16 times more, 16% more memory than Ruby 2.0, which is not bad. For comparison, JRuby runs 2.4 times faster, so the performance is kind of same. And JRuby consumes 18 times more memory. So evaluation, MJIT is promising, still have some issues, need more works. So we don't make any promise. So MJIT is incomplete, very early stage. But MJIT achieves the highest in our criteria. So there's a big chance to make Ruby 3 times faster. Conclusion. Ruby is not designed as a fast language. Performance is not our primary goal. We are trying to make the future Ruby fast without changing the language for the sake of performance. 3 times faster than Ruby. It's hard, but seems possible. Performance will solve many problems. It's community effort. Join us. So, I started Ruby, so Ruby is no longer my language. But these improvement mostly done by community, so it is our language. So So join us to make Ruby better language, be nice to each other, create a better future together. And I say special appreciation to Vlad Makarov, who in charge of the MJIT. So happy hacking and make impossible possible. Thank you. You might have a question to me, but unfortunately I'm not online. So keep your questions in your heart, or maybe you may ask me via, say, internet, mails, Twitter, Facebook, or whatever, or you may ask your question to Koichi. Thank you. Bye.